What's up, geometry? Thanks so much for tuning in for another episode of Math with Mullins. Today we're going to be talking about lesson 1.5, measuring and constructing angles. Our main objectives today are to be able to name, measure, and classify angles, identify congruent angles, use something called the angle addition postulate to find angle measurements, and then also be able to bisect angles. Let's get started with some vocab. An angle is a set of points consisting of two different rays that have the same endpoints. That's what we want to fill in our notes real quick. When they have the same endpoint, they're sharing that makes an angle. You can even see a picture right down here. Okay. A vertex is where the rays meet at an angle, so which would be kind of like the point that they make together. If we have interior and exterior angles are just made of that region that's between the sides of the angle, whereas the exterior of the angle, those are the points on the outside. Just very simple terminology here. Okay. We can always name an angle in many different ways. So we want to make sure that we understand the ways that we're labeling these. The first way you can label it as its vertex, like this is angle A. Again, this sign right here means angle. You can use a point on each ray and the vertex, such as BAC. So look how BAC happens. B is on the outside. We go to A, which is the vertex, and then C, or you can even go vice versa, C, A, B. Just make sure that A, that vertex, is in the middle. And then this part got cut off, but if we use a number such as angle 1, here is that 1 right there. Our first example is going to be drawn by this. It says a lighthouse keeper measures the angles formed by the lighthouse at point M and 3 boats. Name 3 angles shown in a diagram. So one way we can say this, I'm seeing one right here, JMK. This will be the top angle. I'm also seeing angle KML, bottom angle. And then I'm also seeing a bigger angle, ML. So all the way on the outside here for JML. Okay. The next piece, I'm going to have you try. It says write 3 names for the angle. So let's take time now sorry for the interruption. We're going to pause this video, see what you can do by yourself. And when you're ready, click play to check your work. So 3 different ways we can label angle 1. I always start with just the vertex. This is angle Q. Easy. The next way you can do it are the opposite rays. So I'm going to start with P, then Q, then R. So I can say this is angle PQR, and I can also go in reverse. This is also angle RQP. All right. For number 2, this is angle 1 because it's got that 1 right here. One way to describe it, you could say it's also angle Y, or you can even say this is angle XYZ or ZYX. Those are actually 3 different ways. So if you included 3 of those, great. The last one, we have angle E, also can be said by angle 2. We have angle DEF as an option, or we have angle FED as another option there. Next, we're moving on to a postulate. So the protractor postulate is when we look at 2 different angles and we try to find the measurement between them. Usually we're going to be measuring right on, like this example of the angle is an obtuse angle. So this is 140 degrees, but there's some times where there'll be a bisector of that angle. There are 3 types of angles we're going to see today. Acute angles measures greater than 0 but less than 90 degrees. A right angle is exactly 90 degrees. Obtuse angles are greater than 90 but less than 180. And a straight angle measures 180 degrees. This is where you want to fill in your notes. We're going to pause right here, draw and label the types of angles you see, and when you're ready to go on, click play. All right, each one of these is an angle, and we're going to try to find the measurement of them. If you have a highlighter or a different colored marker, this may be helpful to highlight them different colors. I'm going to do that on my screen so you can hopefully see it a little bit better. We're going to start with JHM. So here's J to H and then to M. Notice this is an obtuse angle, so we're going to classify that first. Because I know it's obtuse, my answer should be bigger than 90 degrees, but less than 180. And right now it's in between 140 and 150, so we'll say that's about 145 degrees. For MHK, this is where things can get a little bit more tricky. I'm going to erase my original line and let's look at a different color. So MHK is here. MHK. All right. What I want to make you think about is, where are we at in reference to labeling this? Notice if you even want to start right here, right in here, it's in between 150 and 140, so that's 145. Okay. Over here, it's in between, on that same bottom part, 60 and 50, so that's 55. So to find the measurement of MHK, we will subtract those. 145 minus 55, which is equal to 90 degrees. That would make this a right angle. So again, what I did is I used the number on the bottom to determine which ones I needed to subtract, okay? Because that's the distance between this 55 to the 145. Make sense? The last one we have is MHL. And if you want to pause this video, maybe pause this one right now to where you can try MHL on your own. Go ahead. When you're done, click play, see if you found it right. So MHL, again, I'm going to kind of highlight that here. Here's M, H, and L. And still doing that same thing I did before. Right here, looks like it's at 145. Here, up here is at 90 degrees. And again, we're using not the top number, the bottom number, okay? So all I'm gonna do is take 145 and subtract 90. I'm gonna get 55 degrees, so this is an acute angle. And you guys, I'm sorry about all the interruptions. I'm doing this video after school. For number 7, this one has a few congruent angles, but they might not necessarily be the same exact shape. So it says, identify the congruent angles labeled in the quilt design. One way we know it's congruent is if it has the same amount of rings. So for instance, I'm going to start with angle D, which can be maybe labeled differently by saying it's angle ADC, and angle, we can even say EFG. I want you to make sure you understand that they're equals because they both have this double ring right around angle F or angle D. Even if you said angle F and angle D, that is also congruent. Okay? There is another set of congruent angles, and those have that one ring. So I wanted to point that out to you. The one ring is going to be, we can maybe say that that is, sorry, interrupting again. One of the other ones we can say maybe is angle FGH. So if you notice, G has this one ring around it, which could be also congruent with angle ABC. Again, that's focusing on the vertex B. Both G and B have that single ring vertex. Next, if the measure of ADC is 140, EFG would also be 140 degrees just because they are congruent. Without measuring, is angle DAB congruent to angle FEH? Explain your reasoning. Use a protractor to verify your answer. For this one, we're going to say no. It looks like angle DAB is about, I'm going to guess, 90 degrees. And angle FEH is a little bit bigger. I would even say it's maybe around 100 degrees. Okay, so they are not equal. Okay. The last little bit of items we want to talk about is our angle addition postulate. And that just means if we take the measure of one angle and add it to the measure of another angle, it's going to create that entire angle. It's very similar to that lighthouse activity we saw where we named the different angles in there. So what we're going to do now is practice that. It says, given that KLM is a straight angle, find KLN and NLN. So we know that straight angles are equal to 180 degrees. So what I can do is write an equation where I'm adding these two things together, setting it equal to 180, and then use x to find each angle. Okay, so here we go. I'm going to write 10x minus 5 plus 4x plus 3 equals 180. Okay, first thing I want to do, combine like terms. 10x, 4x makes 14x. Negative 5, positive 3 makes negative 2. Okay, once I get here, it just becomes a simple two-step equation. I'm going to add 2 to both sides. So I get 14x is equal to 182. And then my last step should be to take that 182 and divide by 14. So x is equal to 13. Now that I know what x is, I'm going to plug in x wherever I see an x for each individual angle. So KLN, let's do that first. I'm going to do 10 times 13 minus 5. 10 times 13 is 130 minus 5 is 125. So this angle is 125 degrees. For NLM, I'm going to do 4 times 13 plus 3. 4 times 13 is 52, and 52 plus 3 is 55. Both of these added together, that 55 and the 125 should add together to be 180, and that's how you can also check your answer. Since we did that one kind of together, I want you to take a moment here, try pausing 9 on your own. When you're done, click play, and then check to see if you got your answer right. So EFG is a right angle. That means all this is equal to 90 degrees. Let's first go ahead and set up that equation. 2x plus 2 plus x plus 1 equals 90 degrees. Some of you might have worked ahead already and just put all of these like terms together. So 3x plus 3 is equal to 90. Subtract 3 from both sides. We have 3x equals 87. Then we're going to take that 87 and divide by 3 to find out what x is equal to. X is equal to 29, so now we're ready to plug it in to find the rest of our angles. 2 times 29 plus 2 will give me EFH. 29 times 2 is 58, and 58 plus 2 is 60. If this is 60 degrees, I don't even have to plug it in here. I just know that this should be equal to 30 degrees because together they equal 90 degrees added. Our last example, example 10, says angle MNP is a straight angle. NQ bisects MNP. Draw MNP and NQ. Use arcs to show the congruent angles in your diagram. Find the angle measures of these congruent angles. So first, let's start with angle MNP is a straight angle. That just means it's a straight line. So we're going to draw a straight line. N has to be the vertex. That has to be in the middle. So we're going to put M on the left, P on the right. Okay? NQ is bisecting, and now notice that's a ray. So I'm going to just make NQ bisect, label that Q, and these are congruent angles. So that means they both have to be equal to the same thing, and since this is a 180 degree angle and it's directly bisecting, I'm going to make both of these a 90 degree angle. Okay, and that's really all you had to do for number 10. Thanks so much for tuning in for lesson 1.5, and hope you see you next time.